This is Algebra 1, Module 3, Lesson 15, exit ticket. It says, 1. Each graph shown below represents the solution set to a two-variable equation. We got two variables. Which of these graphs could be represented by a function? Now, easiest way to determine a function with a graph is what? Actually, this one's even easier than asking me. Just look at it. But there's a test that you can run. What? Vertical line test is all you have to do. Does this pass the vertical line test? Yes, because it is paired with only one y, or one x, right? One x, one y. Now, does this pass the vertical line test? No, because there's one x and infinite amount of y's for that one x, right? So it does not. So we can go ahead and go, that does not work, right? It does not pass the vertical line test. Your vertical line test says that it has to cross with only one point. Now, does this pass the vertical line test? Yes, it does, because it only passes through one point on the line. If you were to move that over here, straight down through here, does this pass the vertical line test? Yes, because this dot, oh, sorry about that. This right here is the only point there. So it only passes through one point of that line. So yes, this passes and this passes. So we say A and C. Why? Because they pass. Because each y in the domain is paired with exactly one y. Okay? Each x is paired with exactly one y. That is why. Okay? Now, number 2. For each one that can be represented by a function, define a piecewise function whose graph would be identical to the solution set shown. Okay. So, hold on. For each one, so for each graph, we're going to have to represent that. Well, not each graph, that graph A and graph C. How do we represent that? Okay. Well, what happens with graph A? We would have f of x is equal to what? Well, what would it be equal to? First of all, we would have to say negative x minus 1 when x is less than negative 1. Okay? So if I plug in negative 2, okay, I plug in negative 2 for x, what do I get? Well, a negative 2 minus 1. That is 2 minus 1. So that is 1. So that would be negative 2, 1. Is that a point? Negative 2 on this graph? Yes, that is our point on that graph. So that is a true statement. Now, let's look at for all of those to the right of that point. So that would be when x is, now this one's going to be considered greater than or equal to negative 1. So counting negative 1 and everything to the right of it for our x's, what is it? Well, that's simple. It is just x plus 1. What's negative 1 plus 1? F of negative 1 is negative 1 plus 1, so that is 0. So that would be negative 1, 0. And there it is, right there on the dot. Whoop. Right there at negative 1. Okay, y'all see it right there? That's it. So that's how you would describe A. Now, I didn't write it completely though. Let me finish it out here. And let's count it right here. There we go. Now, graph C, we would have f of x. Now look, we're going to have 3 different ones here, right? For C, we have 3 different ones. What's the easiest one? When x is what? When x is 0, what's y? 0. That's it. Now, let's go to the left. So when x is less than 0, what is it? What is y? When it's less than 0, what is y? Guys, on the graph, look at the graph. When x is less than 0, what is y? When it's less than 0, what is y? Is everybody looking at graph C? It's what? Every y value to the left of 0 is what? Negative what? Negative 2. It's negative 2 to the left of 0 because it's less than 0. Now, when x is greater than 0, what is every single y? 2. There you go. And that's how you would do that.